Today's class, what we will study about general methodology to solve some second order partial differential equation, and what we will do at first, we will actually shorten or resize or reconstruct a simpler version of every partial differential equation given. We will call that so-called simpler format as canonical format, and we will first canonically transform our given equation and we will solve them. But before going to that canonical transformation, what we need to learn that how we will classify the equation at first. So what we will take second order partial differential equation, and for that let us take a dependent variable z, which is given by z as a function of two independent variables x and y. And what we will do, we will rename, or for some for simplicity, or to calculate easily, we will rename some differentiations. Del z del x is equal to p, del z del y is equal to q. We have done it before. Del 2z del x2 is equal to r, del 2z del x del y, which is equal to, by if Schwar's lemma is hold, del y del x, and this is equal to s, and del 2z del y2 is equal to t. With all this, we can actually write a partial differential equation of second order. A general format we can write as capital R, which is a function of xy multiplied with r, plus capital S, which is a function of xy multiplied with s, capital T, again this will be taken as a function of x and y multiplied with t, plus a function of x, y, z, p, q, and which will be equal to 0. So this is a general format, and mind that this capital R, capital S, and capital T, they are continuous functions of x and y, which only possessing partial derivatives defined in some particular domain, say capital D, on the xy plane obviously. So say this is an xy plane and we have taken some domain D, and we will then calculate our R or S or T, etc. Now how we will classify this equation? So where we were, that we wish to classify this equation now. So what we will do now, say on this domain D, suppose there is a point x, y. So we will check that s square minus 4rt's value at that xy. Suppose for some xy this is greater than 0, then we will call at that particular xy this equation is hyperbolic. And if s square minus 4rt is equal to 0, we will call this will be a parabolic one. Similarly, if s square minus 4rt is less than 0, we will call it an elliptic equation. So these are the classification. So what we see, these first three terms of this equation, they are actually the principal part of this differential equation. All those classifications etc. will be depending on this part only. So now to do these classifications, let's do some problems. So first problem, very simple one. This is given as del 2z del x2 is equal to del 2z del y2. So if we write simply, this is equal to r minus t is equal to 0. Now point it out that your capital R is equal to 1, capital S is equal to 0, and capital T, this is equal to minus 1. So what is the value of this discriminant? 4rt, which is equal to, what I see, that 0 minus 4 into 1 into minus 1, that is 4, and that is greater than 0. So for every xy of your domain, you will be having, this will be positive. So this is hyperbolic. for the whole domain. Now number 2. See, the next problem is given in this book is del 2z del x square is equal to del z del y. Now simplifying, we can write it, this is r minus q is equal to 0. Now capital R is equal to 1, capital S is equal to 0, capital T is equal to 0. So simply your discriminant s square minus 4rt is turning to be 0. So, and that is again for all those points xy, whatever be the point in the domain. So for all xy, this equation is parabolic. Next problem, this is given as del 2z del x2 plus del 2z del y2 is equal to 0. So this is given r plus t is equal to 0. So your capital R is equal to 1, S is equal to 0, and capital T, this is equal to 1. So what you see that your discriminant s square minus 4rt, this is equal to this is less than 0, and that is again for every xy. And so for the whole domain, your differential equation will be an elliptic one. Next one, 2 del 2u del x2 plus 4 del 2u del x del y plus 3 del 2u del y2 is equal to 0. Is equal to 2. This is the given problem. So what we will do, see, we can write it as 2r plus 4s plus 3t is equal to 2, right? So we are writing capital R is equal to 2, capital S is equal to 4, and capital T is equal to 3. So s square minus 4rt, that turns to be 16 minus 8, 3, 24. So this will be equal to minus 8, that is less than 0, and this is not depending on any of the whatever be your x and y, this will be always less than 0, isn't it? So to conclude, this is an elliptic equation. Next one, see, the problem given is, just give me a minute. The problem given is del 2u del x2 plus 4 del 2u del x del y plus 4 del 2u del y2 is equal to 0. So again, your capital R, this is equal to or actually firstly we should write it in a simple format, that is r plus 4s plus 4t is equal to 0, where r is equal to 1, capital S is equal to 4, and capital T is equal to 4. So your s square minus 4rt, this turns to be 16 minus 16, which is equal to 0, and independent of any xy, for the whole domain we can write this to be a parabolic one. Next one, this is the 6th problem, and this is given as x y r minus x square minus y square s minus x y t plus py minus qx 2 x square minus y square. So what we get, your capital R is equal to xy, capital S is equal to minus x square minus y square, and capital T is equal to minus xy. So s square minus 4rt we are calculating now, and this will be say x square minus y square whole square minus 4, actually there will be a plus due to this negative sign, and this will be plus x square y square, which is given by x square plus y square whole square. Now see, obviously whatever be your value of x and y, except at the origin, this is greater than 0. Jodi if x and y is not equal to 0 0, and this is equal to 0 at when x y is equal to 0 0, that is the origin. So at origin only this will be a parabolic one, and except origin everywhere this will be an hyperbolic one. Next one, so just to write, this is parabolic and this is hyperbolic. Now next one, x square multiplied with y minus 1 r minus x y square minus 1 s plus y minus 1 t plus x y p minus q is equal to 0. This is the given differential equation. Now see, your r is equal to x square y minus 1, s is equal to minus x y square minus 1, and t is equal to y minus 1. So your s square minus 4rt, that is the discriminant, will be x square y square minus 1 whole square minus 4x square y minus 1 whole square. So you can take common, right? X square y minus 1 whole square can be taken as common, and then the remained part is y plus 1 whole square minus 4y, if I am not wrong, and that is again equal to x square y minus 1. This will be y minus 1 whole square. So finally we get this. So what we get, that follow that if we take the xy plane, then x equal to 0 means this straight line, right? This is x equal to 0, and y equal to 1 means this straight line. So on these two straight lines, this differential equation is parabolic, okay, and for the rest of the whole plane, this should be hyperbolic, because this should be positive only. Okay, so the next problem, 8, xy minus 1 into r minus x square y square minus 1 into s plus yxy minus 1 into t plus xp plus yq is equal to 0. Now let us calculate. Capital R is equal to xy minus 1, capital S is equal to minus x square y square minus 1, capital T is equal to yxy minus 1. So what you get about s square minus 4rt is equal to x square y square minus 1 minus 4xy xy minus 1 whole square. So simplifying, see that xy minus 1 whole square, that you can take common, and then this will be xy plus 1 whole square minus 4xy, and simply see this will be actually xy minus 1 whole square. So finally you get xy minus 1 to the power 4. So see, there will be a rectangular hyperbola on xy plane. So this rectangular hyperbola, which is giving xy is equal to 1, on that on this rectangular hyperbola only you should be having a parabolic differential equation, else everywhere your differential equation is hyperbolic, because this to the power 4 always be gonna some positive number. Now ninth problem, this is x minus y multiplied with xr minus xs minus ys plus yt is equal to x plus y p minus q. So your r is equal to x multiplied with x minus y, s is equal to minus x multiplied with x minus y, and t is equal to y. Sorry, I have made a mistake. I mean there should be a x plus y, because I mean this was my mistake, because if you take s common then this will turn x plus y. So this is this, and t is equal to y multiplied with x minus y. So let's go for that, s square minus 4rt. This s square minus 4rt, now this is x square minus y square whole square minus 4xy into x minus y whole square. Simplifying, we are taking common, x minus y whole square will be common, and then x plus y whole square minus 4xy will be remained, and this will be actually x minus y whole square. So ultimately you are having x minus y to the power 4. Now this is saying that whenever you are on this straight line on the xy plane, that is x equal to y straight line, you will be having a parabolic differential equation, and whenever you are out of this straight line you will be having a hyperbolic differential equation, because this to the power 4 gonna be some positive number. Next problem in this row will be 2y square r minus 2xys plus x square t is equal to y square p over x plus x square q over y. So write it as capital R is 2y square, capital S is equal to minus 2xy, capital T is equal to x square. So let us solve this thing. So s square minus 4rt will turn 4x square y square minus 4x square y square, sorry, this will be 8. If I'm not wrong, this will be 8. Okay, so this is minus 4x square y square. Am I right? So see, I mean we are taking the xy plane, and if x is equal to 0 and y equal to 0, this is y equal to 0, and this one is x is equal to 0. That is on this axis. Whenever you are on the axis, your differential equation is a parabolic one, and whenever you are out of the axis, your differential equation is of some elliptical type, because always this minus of this square will be turning a negative number. Okay, so next one. So in this next part, see, I mean beforehand we have taken two independent variables only. Now we will be shifting towards the independent variables. The number of independent variables should be greater than 2. So what we will do, follow. See, when we were to write the differential equation, the second order partial differential equation of two variables, actually what we have written, watch it carefully. Say if u is your dependent variable with two independent variables, then we have written it as this first, and then we have well, I mean there were some say constant like that, and then or constant or function, whatever you write. Sorry, I mean this is not a constant, this is some function, and 1 2 del 2 u del x2 del x, sorry, del x1 del x2 plus a21 del 2u del x2 del x1 a22 del 2u del x2 del x2, which is equal to some combination of first order differential equations, first order differentiations, say, or write plus some b1 del u del x1 b2 del u del x2 plus some c multiplied with u is equal to 0. See, this is the general way to write this thing. Now when we have written that x1 is equal to x, we have written this as del 2u del x2, we have written this as del 2u del x del y, and this del 2u del y del x, and this del 2u del y2, right? And this was your p and this was your q. Now when your the number of independent variables are larger than 2, then follow that if this is 3, then you have to take like 1 2 3, then 2 1 2 2 2 3, then 3 1 3 2 3 3, like that. So whenever I am taking, suppose there are more variables, so not writing all those terms, not making it cumbersome, we are writing this as a summation. Your I is equal to 1 to 3 and your j is equal to 1 to 3 del 2u del xi del xj. This should be the first term multiplied with some extra term aij. Similarly, I equal to 1 to 3 bi del u del xi and c u is equal to 0. So if you are taking 3 independent variables, then this is your equation, and if you are taking n small n number of independent variables, just replace this 3 by n and your differential equation is done. Now for this thing, what will be the way of minding whether this is elliptic, parabolic or hyperbolic? So you cannot just do some s square minus 4 rt, because there are not only s, r and t available, you have all these aij's, right? Because this will be the principal part, so you will be having, if you are taking n independent variables, small n independent variables, then you should have a11 to ann, so you will be having a n cross n matrix, and this matrix we will write as capital A. This is a matrix of aij. For this case we are writing it's an of order 3 cross 3. Now what we will do for this problem, I mean whenever your number of variables are greater than 2, even for 2 this will be applicable as well. So for this one we will first find out the eigenvalues. Now for to find out the eigenvalues, we will count this equation, that the determinant of a minus lambda multiplied with 3 cross 3 identity matrix, this will be equal to 0. Now what the cases you might have? Number 1, say you will be having all either all those eigenvalues are non-zero, or there may be some zero elements. If at least one eigenvalue is 0, if at least one eigenvalue is 0, so we will call it a parabolic one. If all are non-zero but except only one, all the signs are equal. Suppose you are getting, suppose n minus 1, I mean whenever I mean come to the 3's point, so say 2 are negative and 1 is positive, if such a thing, or 1 is negative, 2 is positive, so I mean 2 I mean you are having some lambda 1, lambda 2 and lambda 3, right? Now suppose your lambda 2 is positive, these two are negative, or suppose this is negative, these two are positive, then you will say that this will be an hyperbolic one. And when say all every non-zero signs, every non-zero one, all of have the same sign, say these 3 are positive or 3 are negative, then you will be writing this to be some elliptic differential equation. Now let us check for this one. The first problem is given as uxx plus uyy is equal to uzzz. So your capital A, this is equal to 1 0 0 0 1 0 0 0 minus 1, right? Because you can actually write it as uxx plus uyy minus uzz is equal to 0. So what we get, see, I mean the eigenvalues of this particular matrix is 1 1 minus 1, isn't it? So what we find that all the signs are same except 1, so this will be a hyperbolic one. Okay, and the next problem, this is given as uxx plus uyy plus uzz plus uyz plus uzy is equal to 0. So we are writing, so capital A is equal to, first we see uxx 1, uyy 1, uzz 1, and zyz, so these 2 points are 1 1, so except that everything is 0, right? So we need to find out the eigenvalues. The first follow that these two rows are similar, right? So similar means what? The determinant of A is equal to 0, that is at least one eigenvalue is equal to 0, so this will be a parabolic one. Okay, so see, this was rather simpler, and let's go for uxx plus uyy plus uzz is equal to 0. So simply see, I mean that will be capital A is equal to 1 1 1, that is the trace 1 matrix, and actually this is an identity one, and all those eigenvalues are equal to 1, all are of the same sign, so this is a elliptic one. Next one, uxx plus uyy is equal to uz. See, this is 1 1 0, so the determinant is equal to 0 and one of the eigenvalues are equal to 0, so this is parabolic. Then uxx plus 2uyy plus uzz is equal to 2uyy plus 2uyz. So we are writing capital A is equal to, see, 1 2 3, there is sorry, this will be xy, this will be xy, extremely sorry, this will be yz. Okay, so xy xy, right? So we can actually write this as uxy plus uyx. So this is minus 1, this is minus 1 as well, and this is minus 1 and this is minus 1 as well, because we can write it as uyz plus uzy. This 2 can be broken into 2 parts, right? So 0 0. Now we have to find out the eigenvalues. So let me check at first. is there any way to, I mean, what I have shown you beforehand, that can we go for some row operation? Say all these rows are added up, 1 minus 1 0 minus 1 2 minus 1, and the next one is 0 0 2. Very good. And then another row operation. Well, I don't find, I have made a mistake, I guess. Sorry, this was 1, right? So this is 0. Sorry for this mistake. So this is saying that the determinant of the A will be equal to 0, and one of the eigenvalues will be equal to 0 as well. So this is a parabolic equation as well. So here I complete this class. From the next class we will be moving towards the solution of such equations. A final part of this class, before going to the canonical transformation and solution, or the procedures of the solutions, we will check what do we mean by characteristics. Now what we will do, see, I mean, we have already written that this will be the general second order partial differential equation. So whenever we are given this equation, what we will do to find this equation's characteristics, we will write first this equation, and then the solution of this equation will be found out, and by then, and this is likely to be in this form, and then we will be solving this equation dy dx plus lambda is equal to 0, and this will give us two equations, two set of families. Actually, these two set of families are called those characteristic equations. What does they actually mean? They mean such a space, suppose in these characteristic spaces, suppose these are the family of first characteristics, and these are another set of families which have been given, which have been drawn or derived. Now if you take these characteristics to be your axis or to be your variables, then what you will have, your given differential equation to be simplified in a particular format, such that you can easily solve these equations. So we will go to some examples. Say first example is y square r minus x square t is equal to 0. Now what you see that when you compare and you wish to find, at first you see that this is an hyperbolic differential equation. Why? Because if you take your s square minus 4rt, you are having 4x square y square which is greater than 0 whenever you are not at the origin. So your lambda equation will be turning to y square lambda square minus x square is equal to 0. That is, lambda is equal to plus minus x over y, and then we need to solve this differential equation dy dx minus plus xy. Am I writing correctly? Oh, sorry, plus minus, okay, and this is equal to 0. Then we will be having two different families of curves. See, the first one is, this is y square minus x square is equal to c1, and the another one is x square plus y square is equal to c2. Now these two families are the characteristics of the hyperbolic partial differential equation. Now if you point it out, these are the families of circles and hyperbolas, right? So these will look like, see, these are these things, and these are those hyperbolas. Like how can I write this? Like this will be like this one. So if you take such coordinates, then on that coordinate your differential equation will be simplified. Next one. So this is given as x square r plus 2xys plus y square t is equal to 0. Now you see that here this differential equation is a parabolic everywhere. Why? Because you see there is x square minus 4 rt is equal to 4x square y square minus 4x square y square, which is equal to 0 irrespective of whichever be your xy. And what is your characteristic generating this equation? This lambda square x square plus 2xy lambda plus y square is equal to 0. That is, you are finding out that x lambda plus y square is equal to 0. So lambda is equal to minus y over x. Only one value can be obtained, right? So solving, what we will have that this will be dy dx minus y by x is equal to 0. So this is dy by y minus dx by x is equal to 0. Integrating, we can see these are log of y minus log of x is equal to some constant. So y by x is equal to some constant whenever we are writing it simply, or rather y is equal to c1x, a straight line passing through the origin. So this is the required family of characteristics. Okay, so if we just plot, these are the family of the characteristics. This is x and this is y. Next example. This is 4r plus 5s plus t plus p plus q minus 2 is equal to 0. So we have to solve. First see that this will be 25 minus 4 into 4, that is 16. This is the your discriminant, that is equal to 9, and this is an hyperbolic differential equation. Everywhere this is hyperbolic. Now this we need to solve. This is equal to 0. So lambda is equal to, can you tell me what will be the value? This is minus 5 plus minus 25 minus 16 over 8. So this is equal to 9, that is 3. So minus 5 minus 3, this is equal to 8, that is the first one will be minus 1, and minus 5 plus 3, that is equal to minus 2, that is equal to minus 1 over 4. So if I'm not wrong, please check. And now to solve this differential equation, dy dx minus 1 is equal to 0. So this gives us y minus x is equal to c1, and this will turn this out dy dx minus 1 by 4 equal to 0, and so this will be 4y minus x is equal to c2. So these two equations, these two straight lines, they will be, that first one will be this one where this cut is 1, and the second one will be this one when this cut is 4 and this cut is 1. So two families of straight lines, that will be the characteristics. Next one, next problem, 4 sine square x multiplied with r plus 2 cos x multiplied with s minus t is equal to 0. Now to find, to find the type, this will be 4 cos square x, that is s square minus 4 rt. I am going to calculate 4 cos square x minus 4 sine square x, which is equal to 1, sorry, this is equal to 4, and this is a positive number always, and this will be a hyperbolic partial differential equation. Now to find the solution of this quadratic, 2 cos x lambda minus 1 is equal to 0. So we have lambda is equal to minus 2 cos x plus minus 4 cos square x minus 4 sin square x, sorry, plus, and there will be a 2. So you have minus cos x plus minus 1 I have, right, because this will be equal to 4 and root over of 4 is equal to 2 and 2 by 2 is equal to 1. So now we will solve this equation dy dx. The first one, cos x plus 1 is equal to 0. So we have y minus sin x plus x is equal to c1, and the next one should be dy dx minus cos x minus 1 is equal to 0, that is y minus sin x minus x is equal to c2. These two are the family of characteristics. If I'm not done it wrong, please check this. Actually I have done it wrong, right, because there should be another sin square x as well, if I'm not wrong. So this will be a cot x and this will be a cosec square x. So cot x plus cosec square x. So cot x, whenever we integrate, this will be log of sin x, I guess, right, and cosec square x will be minus cot x, and so on. So please correct this part, and apology for this wrong mathematics. So this part is not correct, please go and rectify these parts as well. Okay, so these were the characteristics, and now we will go towards the solution for these canonical transformation and solutions in the next class.